This is lesson 3-3. Equations with variables on both sides. One vocabulary word in this lesson is the identity. It means it's an equation that is true for every value of the variable. I'll explain more about why this works a little bit later in the lesson. Now, when we solve an equation with variables on both sides, we use the addition or subtraction properties to get the variable on one side of the equation. It does not matter which side of the equation you get the variable on, as long as you move all of them to one side or the other. Sometimes people like to move them all to the left side. Sometimes people like to move them to try to get them all to be positive. It really doesn't matter as long as you get all of the variables on one side. Let's look at a couple of these examples. We're going to solve 2 parentheses c minus 6 equals 9c plus 2. Now, before we can even start moving variables to one side of the equation to the other, we need to simplify if it's all possible. And it's obvious that we can distribute right here to make it a little bit easier to solve. So 2 times c is 2c, and 2 times negative 6 is negative 12, and that's going to equal 9c plus 2. Now we have c's on both sides of the equation. We need to move them to one side of the equation. Doesn't matter which one. I have a tendency to move most of my variables to the left, so I'm just going to subtract 9c from both sides. These will cancel out. 2c minus 9c is negative 7. c minus 12 is equal to 2. Now it's a regular two-step equation. I will add 12 to both sides, and I get negative 7c equals positive 14. Divide by negative 7, and c equals negative 2. And of course, you can check your equations just like you did before by plugging negative 2 back into the original equation. Let's look at problem number 2. 7k minus 4 equals 5k plus 16. Again, we have k's on both sides of the equation. Remember, the equal sign separates your equation into two sides. That's when you need to move things from one side of the equation to the other. So if we look at this, I could subtract 5k from the left-hand side and subtract it from the right-hand side. And I will get 7k minus 5k is 2k minus 4 equals 16. If I add 4 to both sides of the equation, I now have 2k equals 20. Divide by 2, k will equal 10. All of that is getting the equations of the variables on one side of the equation or the other. Let's look at problem number 3. Again, we have x's on both sides of the equation, so we need to move them all to one side of the equation or the other. Since I've moved all the variables to the left side, I think I'll move to the right side just to prove it really doesn't matter. So I'll subtract 12x here, subtract 12x here. I have, these will cancel. 6 equals 16 minus 12 is 4x minus 42. Right, now I will, since the x is here, I now have to move the 42 to the other side. So I'm going to add 42 to this side, add 42 to the left-hand side. 42 plus 6 is 48. That equals 4x. Divide both sides of the equation by 4, and x equals 22. Excuse me, 12. X equals 12. Now, you do have to be able to set up equations with word problems, and it's really helpful if you can translate those words into an equation. That's really, really, really very important. So, you can buy a skateboard for $60 for a friend and rent the safety equipment for $1.50 an hour, or you can rent all the items you need for $5.50 an hour. For how many hours must you use the skateboard to justify buying your friend's skateboard? In other words, how many hours are you going to have to go and skateboard to make it worth purchasing the skateboard versus renting all the equipment up front? So the first thing we need to do is we need to define our variable. Our variable is normally defined based upon the question they're asking us, which is how many hours. So I'm going to let h equal the number of hours. All right, so h is going to equal the number of hours. I know the cost of my friend's board plus the cost of the safety equipment has got to equal the rental of all the equipment times the number of hours. To make it worth my while, the cost of my friend's skateboard plus the cost of the safety equipment has got to be less than what it's going to cost me to rent everything. So that's what I'm looking at trying to figure out. Okay, so let's look and see what we have. Let's try not to face the problem. Now, the cost of my friend's board, that's $60. Plus the cost of safety equipment. Safety equipment is $1.50 an hour, so 1.50 times the number of hours I'm going to rent it has got to equal the cost of all of the rental equipment is $5.50 per hour. That would be right here. So $5.50 per hour. So $5.50 per hour times the number of hours. So now I have this equation. Okay, this is here, and this is there. So now I just simply need to solve this equation. I have h's on both sides of the equation. It would be so much easier for me to move the $1.50h over to the right-hand side. So I'll subtract 1.50h. That's a funky looking 5, isn't it? So these will cancel. This will be 60 equals 550 minus 150 is $4, or just 4h. Divide both sides of the equation by 4. 60 divided by 4 is 15. Since this is a word problem, I need to write the answer in a complete sentence. So the question, if you remember, we'll scroll back up here. The question said, how many hours must you use the skateboard to justify buying it? You must use the skateboard for at least 15 hours. Okay, so you must use the skateboard for 15 hours. Okay, sometimes you will solve an equation and it will turn out a little bit differently than what you're used to. If you remember the previous equations, we always had an answer. 15, 4, doesn't really matter, it was an answer. We'll get answers here, but they're not going to be exactly what you're expecting. And this is where that identity definition comes back into play. If we look at question 1 here, it says 9 plus 5n equals 5n minus 1. If I wanted to get all my variables on one side of the equation, I'm going to subtract 5n from both sides of the equation. This will cancel, and look, oh wow, that canceled. So now I have 9 equals negative 1. In my entire time of teaching, 9 has never equaled negative 1. Since 9 does not equal negative 1, this is not an equation in which has a solution. Okay, this is not a true statement. 9 does not equal negative 1. Since 9 does not equal negative 1 is not true, the answer to this is there's no solution. This particular equation has no solution whatsoever because there's nothing you can put in there that will make the variable equation, there's nothing you can put in for the variable that will make the equation true. Let's look at equation 2 here. We have 9 plus 5x equals 7x plus 9 minus 2x. Now we can simplify first. I'm going to take my 7x and my negative 2x. Don't lose your negative sign because remember, they're on the same side of the equation. So I have 9 plus 5x on the left-hand side. 7 minus 2 is 5x. I'm going to have 5x plus 9 on this side of the equation. Now, if you remember, the commutative property says order doesn't matter when you're adding. 9 plus 5x is exactly the same thing as saying 5 plus 9x. They're the same. If I decided to get rid of all the variables, let's see, I subtract 5x from this side, I subtract 5x from this side. They'll cancel out. I get 9 equals 9. This is a true statement. Every time I look at it, it's going to be true, which means no matter what I put in for the variable, we'll make it a true statement. This is called an identity. This is that definition that we had at the beginning. Okay? It's where the identity is defined as an equation that is true for every value of the variable. No matter what I put in for x here, I'm going to get a true statement. So we call this an identity. To wrap this up a little bit, an equation can have one of three things happen to it. You will get a solution like x equals 6. You will get an untrue statement like 9 equals -1, and therefore you have no solution. Or you will get a true statement like 9 equals 9, and that is an identity.